Good morning, my YouTube viewers. In this particular video, what we're going to be doing is a practice question concerning the heights of male and female students. So you want to compare the average heights of male and female students in a school. You have a sample of 20 male students with an average height of 170 centimeters and a sample of 20 female students with an average height of 165 centimeters. The standard deviations are 10 centimeters and 8 centimeters respectively. Test whether there is a significant difference in the mean heights of male and female students at a 5% significance level. So we're going to solve this question using Python. And in order to use Python, we have to import the libraries that we're going to need to execute the program. So we're going to import NumPy as NP, which is the numeric library. And we're going to import SciPy.stats as stats, which is the statistical module of the SciPy library. And the SciPy library concerns scientific formulas. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. And now what we have to do is we have to define our variables. So the male mean is 170, the male standard deviation is 10, the female mean is 165, the female standard deviation is 8, the sample size of the male is 20, and the sample size of the female is 20, and the confidence level is 95. So what we're going to do is we're going to generate our sample data. So the first thing that we want to do is we want to set our seed. The reason why you set your seed is because every time you run the program, you want it to initialize with the same values. And so that's what happens when you set your seed. So you've got np.random.seed, and you can put any number you want within the brackets. So now we're going to generate normal distribution for male heights and female heights. So male heights equals np.random.normal, brackets, log equals male mean, comma, scale equals male standard deviation, comma, size equals sample size male. And for female heights equals np.random.normal, brackets, log equals female mean, comma, scale equals female standard deviation, comma, size equals sample size female. So now what we're going to do is we're going to perform a two-sample t-test. So the t-statistic, comma, p-value equals stats dot t-test underscore ind, and I think ind stands for independent, brackets, male heights, comma, female heights. And then we're going to print the t-statistic and the p-value. So your t-statistic is 1.96 and your p-value is 0.570. So the p-value is just slightly higher than the significance level of 5%. So that means you're going to fail to reject the null hypothesis. There is no significant difference in the mean heights of male and female students. And then so your alpha is, which is your significance level, is 5%. If p-value is less than alpha, you reject the null hypothesis. Else, fail to reject the null hypothesis. So since the p-value was slightly larger than the alpha, we fail to reject the null hypothesis. There is no significant difference in the mean heights of the male and female students. And now what we're going to do is we're going to plot the sample heights onto a graph. So we're going to create two histograms to do that. So plt.figure brackets fig size equals 6, 4. So the first histogram is plt.hist brackets male height, comma, bins equals 10, comma, color equals blue, comma, alpha equals 0.7, comma, edge color equals black, comma, label equals male heights. And the next histogram we're going to make is plt.hist brackets female heights, comma, bins equals 10, comma, color equals pink, comma, alpha equals 0.7, comma, edge color equals black, comma, label equals female heights. So now we're going to create some vertical lines on the histogram. plt.ax line brackets male mean, comma, color equals blue, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals male mean centimeter. The next one is plt.ax line brackets female mean, comma, color equals pink, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals female mean centimeters. And then so the X label is height in centimeters, the Y label is frequency, the title is histogram of male and female heights with means. So you get a legend, you get a grid, and you're going to show it. So we're going to show you the histogram of male and female heights with means. So you can see that the blue bars are the male heights and the pink bars are the female heights. The blue mean is 170 centimeters and the female mean is 165 centimeters. So you can see on the chart that the female mean is less than the male mean, but nevertheless, there's a 5 centimeter difference. So there's still not a significant difference in the means of heights of males and females. So if you had changed the significance level, then that would possibly affect the outcome, whether it was the null hypothesis or not. So let's say if you had changed the significance level to 0.01, then there's a possibility that it would reject the null hypothesis because there was not enough distance. There was too much distance between the male and the female heights. But since the alpha is 5%, then it fell within the range, so they failed to reject the null hypothesis. So that completes this video where we've gone through the code. And the next video, we're going to be talking about another practice question. So I look forward to communicating with you then.